one topic that's too easy for y'all. But the first thing that I'd like to start with is the notion of present value versus future value, which in my opinion is probably the most important topic within time value of money. You really want to understand it. And we're going to try to flesh out a problem together with some sort of logic. And from there, we're going to derive the very foundation of what time value of money is all about. Okay? I'm going to ask you all to interact. So we're going to begin with present value, and we're going to mix some interest rates with this. And we're going to jump into an example, and we'll kind of have a conversation about it, okay? So let's do just that. Now, let's see if this is okay like that. And we're going to go up. Okay. So what I'm going to do is I'm going to ask y'all a question, all right? I'm going to give y'all two options, all right? We're going to have two options of an investment, option A and option B. These two options are going to be highlighted right here, by the way. Okay, they're highlighted right here. Option A and option B. Option A will be a payment of $500,000 today versus option B, which will be a payment of $1 million in the future in 8 years. All right. Now, just off the bat, if I have to ask you, what would you rather? Can everybody in the chat just let me know? Would you rather the 500K today, or would you rather the $1 million 8 years from now? Can somebody just tell me what you would want? It's subjective, right? Everybody has their own answers. But in the chat, let me know. Would you rather 500K today or $1 million 8 years from now? Whatever interest rate you believe you could get, just tell me whether you would want option A or option B. But very good answer, Waleed. I love that answer because yes, it does depend on the interest rate that you could get. But okay, so Vanessa says 500K, Marianne says 500K, Waleed says 500K, Brandon says I'm not sure. Okay, that's totally fair. And William says 500K as well. So option A. So most of us are going with option A. Me, myself, I would probably go with option A as well, and I'll tell you why. But Waleed actually brought the answer a little bit, right? It depends on the interest rate. And the interest rate is a very important topic, and we'll talk about it in just a second. But the underlying, I guess, takeaway here is that money is kind of a subjective topic, right? Depending on who you are and depending on what time you're dealing with, you may decide to go with one option versus another. And let's kind of double down on that idea. For us, $500,000 was more valuable to us today than $1 million 8 years from now. Why is that? It's because money in the future may or may not be as valuable as money today. And a very simple way to think about this is that, listen, 8 years from now, we may not be here, right? We may die. It's a very sad truth, but also we may not need the money anymore, or we may have different requirements and or specifications. And even better than that, maybe money that we're able to get today, we could make it work better and make us more money than what we could expect in the future, right? So this is just me trying to begin this conversation that money today may not be worth as much as money tomorrow, and the money tomorrow, right, in the future, may not be worth as much as the money they can receive today. Now, why is that? It's because of this idea of an interest rate. In other words, something that I like to discuss as being, I guess, the opportunity cost. We'll call it like that. So let me just kind of highlight it. Oh, I guess not. This is the opportunity cost. This is something that you'll see a lot in class, and it's going to be thrown at you throughout the whole course, right? They're going to call your opportunity cost your interest rate. And let me tell you why we call our opportunity cost our interest rate, and our interest rate the opportunity cost, and vice versa. Let me tell you this, right? Because a lot of us, we said that option A was better than option B, which is 8 years from now. But Waleed brought up this idea of the interest rate. Well, the reason why the opportunity cost is called the interest rate is because what if I told you that you could take the 500K today, but you could also invest your 500K because you have an amazing investment opportunity that's going to yield 20% per year. In that case, if you're able to yield 20% per year, that's a big amount. That means that you're essentially getting a fifth of your money every single year. For you, it may be better off to get that 500K today. Now, I feel like I'm talking a lot, and I don't like talking a lot. So what we're going to do is we're going to throw an example at us, okay? So can somebody give me a random all right, a random opportunity cost. Somebody give me a K, any number, anything. It could be 5%, 10%, a million percent. You decide. Can somebody just throw at us a, okay, well, Lee says 55. Geez, okay, all right. Well, let's go with 55. Why not? Why not? So what I did is if we use an opportunity cost of 55%, right? And we'll do it just for jokes, is I actually built two timelines that would highlight what would happen and how should we try to contextualize this idea of an interest rate and this idea of time value of money. So we went with option A, all right? And to make it more like serious, I'll go to an opportunity cost of 10%. But let's say we went with option A and we know that we could invest anything that we have at an interest rate of 10% per year, okay? We have the opportunity to make 10% on our money per year. So let's look at that option. If we were to take option A, if we were to take 500 grand today, well, how much would that be worth for us 8 years from now? So if we look at our timeline, right? If we look at our timeline here, we notice, look at that, 500K that was taken today and invested at 10% would give us a future value 8 years from now of $1 million approximately, or $1.1 million approximately. Why is that? It's because we invested our money every single year and we took the money, the interests that we made, we added that back to our principal and we reinvested it year to year to year up until year 8. So obviously, it seems that $1 million, 71,794 is bigger than $1 million that we were going to expect at year 8. And for that reason, it seems like option A was the better decision, okay? But now let me ask y'all a different question. What if our opportunity cost was 6% or even 5%? Would option A or option B be better? No pun intended. Can somebody tell me in the chat, if our opportunity cost was 5%, what option would be best, option A or option B? So Vanessa says B. Do other people agree that perhaps option B would be a better option? Well, yeah, look at that. Because if our opportunity cost, if we only have the ability to invest our money that we receive today, i.e. 500 grand at an interest rate of 5% after 8 years, okay, which is exactly what we did, Waleed. This is essentially finding the future value for us. After 8 years, we notice that, okay, it's $738,000. So taking $1 million 8 years from now is way worth it. All right. Now, to give you more context on what we just did, what we did is that we looked at two alternatives, right? Option A versus option B. All right. And based on the interest rate, one option will be better than the other. That's really the foundation, the fundamental concept related to time value of money. But there are two ways for us to do this. And right now, I'm going to kind of build off that intuition and also throw at you an example that I want you to do. Okay. So what we did here is that we took our money that we were supposed to receive today, which was 500K. So that's our present value. And we said, okay, well, if we take our present value and we do 1 plus K to the power of N, what would be our future value? All right, that's exactly what we just did now. We found the future value of option A, which is receiving money today, and then we compounded interest to it to see whether the future value of taking option A would be bigger and or smaller than option B. Okay, is that clear to everybody that essentially we took the present value of our money, which is 500K, then we did that multiplied by 1 plus K to the power of N, and that gave us an amount. That amount we compared to the option B, which was of $1 million. And because our future value is smaller than option B, okay, because our future value is smaller than option B, then obviously it's not a good idea to go with option A. Is that clear so far for everybody? Quick yes or no in the chat, just for fun. Okay, this is a very important like intuition to understand. Okay, solid. Now that's one way of doing it. But another way for us to do this, all right, is to simply do it from a discounting interest perspective, all right? So let's say that we're considering to go with option B. We're like, okay, let's go with option B. Let's go with $1 million, but that's only happening 8 years from now. And once again, we know under the topic of time value of money, money in the future may not be worth as much as money today due to the fundamental concept of interest, of compound interest, of the opportunity cost of investing money today and getting something bigger into the future. So for us to understand, well, what is the actual value of that $1 million we are set to receive 8 years from now, we could actually discount that figure. So what we can do is we could seek the present value of $1 million by discounting it. So if you were to take $1 million, okay, and find its present value with the following formula, you would do simply $1 million divided by 1 plus k to the power of what? Can somebody write it in the chat? We do it to the power of what? What is n? Is n 0? Is n 5? Is n 1,000,000? Is n 10,000? Is n 3? Is 8. Perfect. Amazing. All right. And with that, we'd be able to find that our present value is of 676,839. Now, this is super cool because the present value of option B is bigger than option A. And for that reason, option B is better. Okay. So this is a very important topic. And to kind of tie a bow around all this is clearly, it's very obvious to us now that depending on when we are to receive money, and also depending on the interest rate that we have, our decision-making related to money will be different. And that's exactly what Comp 308, what an Intro to Finance course tries to flesh out for you, okay? And before we proceed, do we have any questions? Is this clear? Are we ready to kind of look at this idea of the effective periodic rate and the idea of the quoted rate? Are we good so far? Quick yes or no in the chat. Yeah, sure, no problem. Here are the two examples. There you go. Are we good so far? Do we have any questions? Do we understand time value of money? Do you understand how we could go from present value to future value and from future value to present value? Are we good so far? Amazing. Okay. So, okay, Waleed, I love that question. So the present value is going to be this right here. Okay, this right here is going to be like a value, a dollar. Okay, so this could be payment. This could be a PV at a later date, and then you would put that over 1 plus k to the power of n. Once again, the reason why we're discounting a future cash flow is because, once again, we understand that $1 million, right? $1 million 8 years from now, well, for sure, it's not going to be worth the same to us today. So we're going to take that amount, we're going to divide it by 1 plus the interest rate to the power of n, okay? And that's going to give us the value of that future cash flow to us today. Once again, the reason why it's giving us the value of that future cash flow to us today is because we know that if we were to invest the same amount today at the same interest rate, we would get the same amount in the future. So let me just give y'all an example, just for fun. I'm gonna be annoying. I'm so sorry. Just one more minute. Can everybody in the chat, wow, I sound like a ghetto Twitch streamer, but can everybody in the chat just do, yeah, we're comparing the two formulas and they're literally the same thing. But can everybody just do 676,839 multiplied by 1 plus k to the power of n? Essentially, what we're doing is we're trying to find the present value, the future value of this amount. So take this amount and find the future value at year 8 for this amount. Okay. Could everybody do that to me and tell me what you get? I want the exact decimal points and everything. Okay. Everybody just do that for me. You'll see why. It's my last request before we move to interest rates. Everybody give that a shot. So 676,839 times 1 plus k to the power of 8. So we're going to compound interest to that value. And I want y'all to tell me what does that give you at period 8. And that's going to tie everything up, tie everything in together it should kind of triangulate on what we just discussed. And after that, when you look at the recordings, you'll get to really get the aha moment, I hope, if not already. So yeah, everybody give it a shot. Use your financial calculator. Do 676,839 multiplied by 1 plus, by the way, if you want the K, my bad, it's 5%, multiplied by 1 plus 0.05 to the power of 8. So K is equal to 5%. Everybody in the chat, I need at least 3 people. Come on, at least 3. Okay, Waleed has a number. I need maybe like 2 more people to give it a shot, just so I see y'all are doing it. William, thank you so much. Waleed, thank you so much. One last person. What did y'all get? One last person. Moichido. One last person. Okay, well, listen, I won't waste any more of your time. But obviously, Waleed and William, if we were to round that number up, we would get $1 million. Okay? We would get $1 million. And that's quite literally the idea that this formula for discounting cash flows from the future and this formula to compound interest to see how much money we would have in the future is quite literally the same thing. And it's going to bring us to the same exact answer and the same exact decision. So that's why I kind of wanted to like tie it in for you. So if you're asking yourself, why are we discounting future cash flows? Okay. The reason why we're discounting future cash flows, once again, and I'm saying it again, is because money in the future may not be worth the same as today. And that monies that we're expecting in the future, if we were to discount it, is going to give us, well, in this instance, 676,839. All right. Now, what is that number representing? Like, what does it tell us? It's telling us that if you were to invest $676,839,000 today with the same interest rate for 8 years, you would get that future value of $1 million. Hope it makes sense.